In October of the year 2023, deep within the dense rainforest of French Guiana, a routine expedition took a terrifying turn. A group of 11 eco-tourists were walking near a remote campsite. Among them was a 29-year-old woman taking photographs. Suddenly, without warning, a massive dark shadow dropped straight from the forest canopy. Before anyone could react, an adult harpy eagle struck the back of the woman's head. The bird remained attached, locking its grip with its wings fully spread. Her companion had to strike the predator repeatedly with a shoe just to break its hold. The victim survived, spending 7 hours traveling to a hospital to treat multiple deep scalp wounds. This was not a standard hunting mistake. It was a demonstration of raw mechanical force. The harpy eagle is not just a bird, it is an airborne apex predator. Females weigh between 13 to 20 pounds, making them as heavy as a medium-sized dog. Standing nearly 1 meter tall, their straight, two-legged posture on a branch looks unsettlingly human. But their true weapon is hidden in their feet. Each talon is longer than 2 inches. When those claws close, they exert a crushing grip force capable of puncturing bone and stopping prey in seconds without a struggle. With a wingspan reaching up to 4 inches, this creature rules the tropical canopy with absolute authority. Yet, this violent encounter opens a much darker chapter in scientific history. Why would an apex predator with this level of destructive power attack a human? To find the answer, we have to look back at a controversial experiment. An experiment where researchers deliberately released 2 of these deadly birds onto a closed island, populated by thousands of completely defenseless monkeys. What happened next horrified the scientists. To understand how a top-tier avian predator ended up striking humans in a rainforest canopy, we must examine a systemic crisis. The presence of the harpy eagle across Central and South America is rapidly fading. Across its traditional hunting grounds, and the total distribution range of the species has declined by more than 60% due to continuous deforestation. This loss of primary habitat has transformed an apex predator into a solitary survivor, pushing it closer toward localized extinction. Faced with this collapse, conservationists attempted direct human interventions. From the year 1987 to 2006, strict captive breeding and reintroduction programs were launched. At a highly controlled facility in Boise, in the United States, scientists monitored adult pairs behind one-way glass, attempting to produce viable chicks. In the year 2001, these efforts expanded to Panama with the establishment of the Neotropical Raptor Center, gathering individual birds from multiple regional zoos to maximize genetic compatibility. However, artificial breeding met a severe biological barrier. The natural reproductive pace of the harpy eagle is exceptionally slow. A healthy pair raises only a single chick every 2 to 3 years. The egg requires nearly 2 months of constant incubation, followed by an additional 6 months of nest care, and up to 2 full years of parental dependency before the young bird can hunt independently. Because of this timeline, the death of one adult effectively erases an entire generation. Many introduced pairs rejected each other for years, leaving conservation centers with minimal population growth. By the late 1990s, traditional captive methods were failing to keep pace with habitat loss. This stagnation forced researchers into a desperate alternative strategy. They needed a living laboratory, a natural, contained environment where they could study the species and accelerate field adaptation without the risks of the open mainland. The ideal site was already available. In the early 20th century, the construction of the Canal Panama blocked the Chagres River, flooding the surrounding tropical lowlands. This massive infrastructure project created Gatun Lake, and in the process, isolated a 15 square kilometer patch of high ground, forming a unique artificial island known as Barro Colorado. In June of the year 1999, scientists released one male harpy eagle onto this isolated territory. A female followed shortly after in October of 1999. Both individuals were fitted with specialized radio transmitters, allowing research teams to track their movements step by step. On paper, it was a perfectly contained sanctuary designed to preserve a dying lineage. But the scientists had overlooked a critical historical factor. A hidden variable had been developing on that island for nearly 100 years. The hidden variable on Barro Colorado Island was a behavioral anomaly developing over a 100-year period of absolute isolation. When the rising water cut the landmass off from the mainland, it altered the evolutionary path of every resident species. On the mainland, primate communities survive in a state of continuous caution. They constantly monitor their surroundings because large ground-based predators occupy the same territory. However, on this new island, major land carnivores like jaguars and pumas were completely absent. Without these natural checks, the ecosystem entered what biologists call a predator-free equilibrium. In this enclosed space, primate populations faced no external pressure. Surveys eventually recorded around 65 howler monkey troops living on the island, totaling nearly 200 individual primates. Populations of capuchin monkeys, tamarins, and sloths experienced similar unnatural increases, multiplying to a density many times higher than the surrounding rainforests of Panama and Costa Rica. It appeared to be a flawless wildlife sanctuary, but an environment with zero threats creates a severe evolutionary flaw. Over a century of safety, the primates did more than just multiply. They slowly shed their defense mechanisms. Fear is a highly demanding mental and physical state, requiring immense metabolic energy and constant alertness. Without predators to trigger this system, the software of their survival instincts became obsolete. The monkeys relaxed. They stopped scanning their surroundings. And most importantly, they completely lost the habit of looking upward into the forest canopy. Danger from above had never existed in their history. This complete loss of vigilance turned the island into a dangerous paradox. The primates were thriving numerically, yet they were biologically defenseless. The entire Hondao had become an artificial garden of naivety, where thousands of animals spent their lives in absolute vulnerability, totally unprepared for an ambush. Introducing 2 harpy eagles into this specific environment was not a standard introduction of a native species. It was the insertion of an apex aerial weapon into a stationary feeding trough. The monkeys did not possess a single defensive protocol to address a threat from the air. From the perspective of evolutionary biology, a biological trap was now set. The moment the birds began to hunt, the scientists witnessed a pattern of destruction that shattered the artificial stability of the island completely. The introduction of these predators immediately triggered a Tonkoke chain of events. Data collected from satellite radio tracking devices revealed a level of hunting efficiency that shocked observers. In less than 12 months, 100% of the monitored howler monkey troops on Barro Colorado Island suffered casualties. The 2 birds established an intensive predation routine, executing a successful kill every 3 to 5 days on average. Field recordings documented a 49% attack success rate for the female harpy eagle, while the male achieved a 38% success rate. These figures represent an exceptionally high efficiency level for ambush predators operating within dense tropical foliage. During the observation period, the male individual captured 25 prey animals across 9 different mammal species, while the female secured 46 prey items, representing 8 mammal species and 1 reptile species. Faced with this relentless pressure from above, the primate community underwent a rapid behavioral transformation. The initial weeks were defined by total panic, as groups scattered chaotically without locating the source of the danger. However, within a few months, a forced adaptation occurred. The monkeys began to recognize the distinctive flight audio of the eagles, detecting the faint sound of feathers cutting through the air. Their daily routines changed completely. Resting periods dropped sharply as individuals reallocated energy toward vigilance. Troops moved closer together, and adult members began rotating guard duties. Most significantly, the primates developed an entirely new vocalization pattern, a specific alarm call reserved exclusively for threats descending from the sky. But this behavioral awakening was not enough to save the system from a mechanical collapse. On a confined island, the biological stakes rose too high, too fast. The intensive hunting pattern did more than just remove individual primates. It actively dismantled their social architecture. In primates, 1. Survival relies on a strict bidan structure. When an adult female or a dominant male was extracted by the eagles, it was like pulling a main supporting pillar out from a structural bridge. The entire care chain broke down instantly. Dependent infants lost protection. Mating structures destabilized, and physiological stress levels soared, causing a severe drop in reproductive rates. Some howler monkey troops lost between 30% to 40% of their total members in a matter of months. The Hondao was simply too small to absorb this level of pressure. By August of the year 2000, after nearly one full year of observation, the experiment reached its breaking point. Realizing that the unchecked predation would lead to a total localized extinction of the primate population, the research team intervened. The experiment was officially terminated. Both harpy eagles were tracked via their radio transmitters, recaptured safely by field biologists, and permanently removed from the island to prevent a complete ecosystem collapse. The sudden collapse of the primate population exposes a deeper architectural error in the experiment. To understand why this intervention failed, we must look at the physical geography of the landscape. In vast, continuous ecosystems like the Amazon mainland, a single breeding pair of harpy eagles requires a continuous habitat range of approximately 100 square kilometers to hunt and sustain themselves. This immense space functions as a natural ecological corridor. It provides the prey populations with broad buffer zones, allowing groups to migrate, disperse, and recover their numbers in untouched foliage. Under these conditions, the avian predator acts as a stabilizing mechanism, extracting only the slower, weaker individuals and strengthening the overall genetic health of the species. However, a severe geographical contradiction occurs when you transition from a vast diloc to an isolated landmass. Barrow, Colorado Island offers a confined, rigid territory measuring only 15 square kilometers. By introducing a top-tier avian predator into this closed system, researchers did not replicate natural evolutionary pressure. Instead, they triggered the enclosure paradox. Without an ecological buffer zone and with no physical corridor for escape, a balanced wildlife mechanism shifted into forced predation. The Hondao essentially functioned as a roofless cage, locking the predators inside a high-density feeding ground where the prey had nowhere to hide or retreat. This structural limitation uncovers the core blind spot in the scientific framework of the experiment. The research team attempted to re-establish a healthy food web by introducing a missing predator, but they miscalculated the impact of spatial fragmentation. In a true rainforest ecosystem, multiple large carnivores compete for the same resource, preventing any single species from applying uniform pressure on one population. But on this island, the eagles operated without competition, concentrating 100% of their hunting force on a defenseless, restricted primate community. The experiment proved that you cannot reconstruct complex natural balances inside a fractured geographical boundary without turning natural regulation into systematic destruction. The structural breakdown observed on this artificial landmass forces us to reframe the entire architecture of modern wildlife conservation. In response to habitat fragmentation, current global initiatives have transitioned toward economic compromise models. In the primary forests of Brazil and Panama, conservation groups now collaborate with local communities to construct elevated observation towers near active nesting sites. This ecotourism mechanism generates direct financial revenue for local landowners, establishing a clear economic incentive to preserve the standing forest canopy without relying on traditional steel fencing or armed enforcement. However, this market-driven protection operates within a highly vulnerable matrix. Data collected by the IUCN and BirdLife International indicates that the global harpy eagle population has declined to a critical threshold, with some regional assessments estimating only 1,000 to 2,000 mature individuals remaining in the wild. In Panama alone, field data suggests that fewer than 450 wild individuals survive. These scattered populations remain confined to increasingly isolated patches of forest, cut off from one another by hydroelectric dams, agricultural expansion, and expanding transportation corridors. This brings us to the definitive payoff of the Barrow, Colorado experiment, and the true source of panic within the scientific community. The field researchers were not horrified by the physical power of the eagle talons or the efficiency of the hunting data. Their real terror came from a systemic realization. They discovered that the modern network of protected sanctuaries, the national parks surrounded by urban sprawl, the fenced reserves, the isolated biological islands are not saving wildlife. Instead, they function as an invisible evolutionary trap, an artificial safety mechanism that actively erases the survival software. the defensive alarm systems, and the adaptive traits developed over millions of years of natural selection. By sheltering vulnerable species inside small, managed enclosures devoid of apex predators, human management inadvertently triggers genetic and behavioral degeneration. The moment a dynamic threat re-enters these artificial spaces, the resident populations face systematic destruction rather than evolutionary adjustment. This realization invalidates the traditional doctrine of isolationist conservation, showing that an environment without pressure is a biological dead end. Ultimately, the crisis on this Hondao leaves us with a fundamental systemic question. To prevent the collapse of global biodiversity, should human intelligence continue to expand its engineering of the natural world, operating as an interventionist manager of ecosystems, or must we learn to execute a calculated retreat, protecting vast, unbroken geographic corridors so that nature can regulate its own balances? Share your perspective in the comment section below, and subscribe to follow our continuous investigation into systems where human solutions become the catalyst for systemic failure.